Yeah, the
or even mysterious wedding party pictures. Maybe especially that.
oh yeah, those are yeah, those are an interesting piece of history.
Even mysterious wedding party pictures.
Oh, I didn't hear him feedback.
Maybe especially that.
Oh yeah, those are yeah, those are an interesting piece of history.
Even mysterious.
Oh, we're on live. Oh, hit the live button. Hello, everybody. This is Greg Allison with the Galactic Gregs coming to you live on the 3rd of February, 2022. Time on deck is 21:06 hours Central Standard Time, Central Daylight Time, excuse me, Standard Time. I wasn't expecting to be live yet, so I got kind of surprised by that. So bear with me, guys. I got a special guest with us tonight, Gary Barnhard. And tonight we're going to be talking about saving the ISS. And the whole proposition here is that NASA has proposed that in 2030, they're going to dispose of ISS by dropping it in the drink. Now, the ISS is quite a facility. It's got quite a lot of capabilities, but it's got some issues too. It's just aging. So how can we save it? What can we do? Is it possible? It just so happens that Gary and I have been partners in crime on developing ISS back in the early days. We both worked robotic systems integration, and I worked ISS on other stints, including power systems and avionics, sensors, distribution, cabling, networking, all in the nodes 2 and 3. And I have worked external payloads. So I've got quite a bit of experience working ISS, as has Gary. And Gary got quite involved in another proposition to basically save ISS on another occasion, or just it was a modification. So with that, I'm going to introduce my friend here, Gary Barnhard. Gary, what say you about this?
Hey, well, it's a pleasure to be here. The situation is this: the ISS is an extraordinary investment that we have made, and one which is, continuing to return dividends in its existing configuration. And as we go forward, if we evolve it, it can continue to be useful in any number of different capacities. So the bottom line is that in 2031, which is when they propose, it does not need to find its way into the Pacific Ocean. What it needs to happen is between now and then is that we have to figure out how to evolve the station, move it to locations where it can be better, better supported, if you will, and whatever it ends up being transformed into, that it is a represents a stable proposition. The big problem that exists with respect to anything associated with such a task is that the station is the biggest thing that's ever been built, off planet by a long shot. From that standpoint, no one wants the liability, for dealing with it should it come to reentry. And so the question comes in is that, well, you sort of have to figure out what your end of life strategy is and work your way backwards from that. So whether or not, and my proposition is whether or not you end up, with the station eventually as a museum or a emergency safe haven, if you will, even those outcomes at the end of life make sense to raise its orbit to a level akin to where we have the space telescope now. Even could even be significantly lower than that, but just significantly higher than the 400 kilometers average altitude that it has now. Where the issue is that the space station is about the size of a U.S. football field, both in terms of length and width, and the frontal area that it presents to what amounts to being, it's not an atmosphere as we know it, but there's enough material there that it ends up being a situation where there's significant drag where station happens to be. If you kick it up, 100, 200, 300 more kilometers, it changes that dramatically. Basically, the space telescope's at like approximately 700 kilometers, and that's considered a 100-year orbit. Nominally, in terms of where something lasts without it having to be rebooted.
Well,
Rebooted.
What's a 100-year orbit?
Approximately. Well, the space telescope with its mass, existing mass is approximately 700 kilometers.
Oh yeah. Well, ISS has got a lot more surface area, so it might not last 100 years at that orbit, but it would certainly last longer. Right.
So the idea is that there's a location that we can, from where space station is now, and still staying below the Van Allen radiation belts, where we will not have to worry about reboosting station for decades. Whether or not it's just multiple decades or 100 years, we want to be able to go through and make the case that we can get station to a place where it can both continue to be useful and it's affordable to maintain its orbit. So the way you go through and you deal with the liability concerns is that you create a test bed environment, and you prove out how you can go through and use a combination of low thrust, long duration propulsion capabilities and higher thrust, shorter duration capabilities, and how this can be an integral part of how station maintains its both its orbital altitude and it's integrated into its general operations. That's why what we've worked on before is a proposal for a advanced propulsion test bed. The idea in this particular case is to use water as your fuel, and the way your test bed works is you work your way around what amounts to being the triple point or quad point diagram for water, where you can store water as a liquid, you can store H2O as ice, you can go through and have it as a gas, you can separate it into its constituents of hydrogen and oxygen. But in general, what we'd like to go off and do is be able to develop systems that can have the propulsion capabilities be as benign as possible. Basically, follow a safety first edict on it, and be able to demonstrate that we have the tools. And one, in orbital dynamics, you have something called a Hohmann transfer, which is basically how you move something from one orbit to another with what constitutes a minima, if you will, in terms of the delta V, or change in energy that's required. And what turns out that is looking at it from in a sense a reduced problem. Basically, you're turning it into a simpler physics problem to solve, and it gives you some pretty good answers for conventional propulsion systems. Where you're worried about something taking the shortest time possible to get from one place to the next. It turns out, though, that there are a number of options. They're They're referred to as low energy trajectories or alternate minimum energy trajectories, weak stability boundary transfers. Depending upon wherever you are working professionally, they have a little bit of a different name. The bottom line is that if you're willing to allow time to be a variable, and you have a long duration, low thrust capability, and a short duration, higher thrust capability, and you're willing to do the math, you can dramatically alter the delta V requirements or the change in energy requirements to move something from one orbit to another. When we did this,
let me pine in on that. So what Gary's talking about here is that your higher thrust engines tend to be lower efficiencies, like your liquid propulsion systems, whereas there are a whole smorgasbord of low thrust engine options that give you far more efficiency in the use of the fuel, which gives you what he's talking about, delta V, which is pound thrust per pound fuel used for the layman in the audience. So, and we do have a few lay people in the audience, by the way, a couple of flat earthers appears. So they're telling us it's all bubbles and wires, Gary.
Okay.
So, but anyway, so what one of the great options is here that he's kind of alluded to a little bit is the idea of using a resistor jet, a water jet thruster, by using water as the fuel. Now, the beauty of that is you have wastewater on the space station, as long as you get people involved with it and processes going on inside there. And, with space shuttle, they used to dispense of this water, and sometimes they would even one time they even had a little icicle that they was afraid of on the side of the space shuttle. They thought it would damage the heat tiles. So I don't know who remembers that. But the water actually can be used as a fuel. Now, it won't have as high a specific impulse as, say, an ion engine, but it has a very high specific impulse, and it's something you would like to get rid of anyway. So it's a fuel of opportunity. And it just so happens that this was one of the original proposed systems for reboost and attitude control of the space station in the early days. And it was to use these resistor jets. And a guy I used to work for, who's passed away, the late George McKay, he was heading this project up. And one of the test engineers is a guy who still works at NASA. He's now down at KSC, I believe, John Hudeberg. And they tested these water resistor jet thrusters running for thousands and thousands and thousands of hours and never had a problem or any issue with them. So this is a very valid way to boost your space station. It gives you a little higher thrust than, say, maybe a xenon ion engine. So it's a very interesting thing to do for station attitude control and reboost for any number of space facilities. Actually, I think Max Vijay proposed this for his old industrial space facility concept, which was to be a competition with space station that NASA squashed because it didn't want competition. So it might be that this is what we would do here for something like this if we want to reboot station. What you could do is you'd have to run the plumbing out to wherever you want to put these resistor jets, but there's these attachment sites on the truss that you could put this and many other payload opportunities out there that Gary and I may talk about in a little bit, called attached payload sites, or APAS basically. And they connect into these things called utility ports. And Gary and I wrote the change request that established the utility ports with the utility distribution going through the truss system on the International Space Station back in, probably 90, 89. I think that's probably back in 1990 time frame, right, Gary?
Mm-hmm.
And so we were writing that change request to get that established. So we're familiar with these utilities that's out there in that. We're familiar with the attachment sites, and we both very well intimately know the robotic systems on space station that can install all these things. So the space station manipulating system, which is the big long Canada arm, which can inchworm end over end thanks to latching end effectors on it, and the power data grapple fixtures up and down the space station. There's also a special purpose dexterous manipulator, which Texans used to call SPIT'em, which the Canadians always hated. They call it Dexter now. It has this ORU tool change-up mechanism is the end effector on it, which has a little bolt mechanism in it and various other things. And there's all kind of attachment. Well, I'm not going to get all in the interface standards here that Gary and I worked at great detail, but we know how these things can be done. So it's quite possible to do this, to put these resistor jets on station, keep it reboosted, and take it up to a higher orbit. It's just like Gary said, if you're willing to take the luxury of time, and why not, as opposed to chunking it in the ocean. There may be some why nots. I've had people suggest that we don't want to put people at risk at the station. Well, we do know this. You know, the metals fatigue over time. Space is a very harsh environment. Space, you're going around the Earth. You're cycling from minus about 250 degrees, about 250 degrees positive. You've got the vacuum, you've got atomic oxygen, a lot of stuff out there that's putting a lot of stress on the structures of the International Space Station. That survived this long is a testament to the engineering that's done after we put up the long duration exposure facility and saw what happened to it. But you know, there's fatigue just from the pressure vessels. The seals need support of some type. So you know, we got to go back and look at what it would take to keep the station going. Gary, what do you think about that? What do you think about this idea? The space station is very expensive to maintain. How would we maintain it and keep it going beyond its design service life?
Well, NASA ended up doing a fairly extensive study on this a number of years ago. The brave soul that was in charge of that was pressed on this question as to exactly how long space station could really live. And what they had gone off and done is, as he explained, they had done an extensive analysis of what were the limited lifetime components and what it would take to deal with it. And he said, listen, you can keep that up. We can keep station up as long as we're willing to put the resources in to make it happen. That's the bottom line. There's nothing there that can't be either maintained or evolved past. Okay, in some cases you replace, like what they've done recently is they've replaced solar arrays, and they've replaced batteries. There's been a massive upgrade program that's been going on with respect to the station. And the idea is you can continue that as long as you care to. Now, what is different or will need to be different is the use of the station will change. Okay, one of the first things that will probably move off the station are things that require a more extreme microgravity environment. Those are better served in a place that doesn't effectively have gym equipment, running on a daily basis, and to keep the astronauts healthy, and doesn't have a lot of other disturbing activities in the station environment. So there'll be an evolution of things that get moved off of it, and eventually it'll arguably it'll become a construction shack for new capabilities that we'll see in an evolving commercial world. But what you have to basically go and do is for each one of, so we've got the answers from NASA when they didn't have any having anyone pushing any particular agenda on it, was that you can keep the damn thing up as long as there's a political will to do it. Okay, so that's it's not how you would evolve it, though does need to be understood for every one of the distributed systems and elements on station. We should go through and have a life cycle plan for it, for both what we can use that's there, what we can learn from it, and how we can either extend it, expand it, or evolve it. Curiously enough, a few years back, there was NASA let out a solicitation to explore what could be done with respect to the commercialization of station. And we me with a team of approximately 29 other folks got together and wrote a proposal basically explaining what I've just been saying here now, that what needs to be done is that we need an evolution plan for the station that's actionable, that brings brings in the commercial resources and allows for the station to become a piece of infrastructure that can be built upon, for both government and commercial endeavors. And at the time, NASA's response was, we don't understand the question that you're answering. Now, as it turned out, of course, that I was, what we ended up providing was an answer that it was not what they were looking for at the time. But things evolve, as does as does NASA in its variousness under its positions, and as does the commercial environment. So we can go through and press on to what the space station was designed to have, an evolving level of automation and autonomy. Some systems were more more diligent in applying those requirements than others. Some were more successful at it. We need to continue that process, because for any form, from any form of building infrastructure in space, if you have something to start from, it's a whole hell of a lot easier to get to where you're trying to go, than if you have to start from scratch.
Right, there's the point right there. That's what we got to pick off on from. Space station has over 100 kilowatt hours of electrical power. Space station has utility distribution through an external truss. Space station has attached payload sites where you can put payloads, experiments, and do different things. One of the things that you've been a champion of, and that you've talked about quite a bit, is using the space station as a power transmission test bed for things like power satellites and other technologies of that sort. It would be easily used for that because it's already got the power. It's already distributed through the truss. All you'd have to do is put a transmitter out there on one of those APAS test sites. And maybe we could even extend the truss and have additional test sites put out there, other APASs or other places to use as attachment points for a construction test bed. Now, what you mentioned was having it as a construction test bed. We had this idea for what we call the Space Operations Center back in the early days before space station really got formulated. And a lot of us within the old Five Society and space advocacy community were real strong chomping at the cord to promote this idea of a space station, to have a space operations center where we could assemble bigger missions to go out into space and do grander things than we might ordinarily take up in the rockets that we had at the time. And to be able to stage things like orbital transfer vehicles. So in space station, when it originally started out, it had what we called a double kill, and it had this big truss that had the box shape to it. We showed like a hangar out there for assembly and things like that. And in all the many various and sundry budget cuts, that many other capabilities were cut out. It's kind of funny. For over a decade, every year they would do a budget cut on the ISS, and we always cut capabilities, but it extended the program another year in duration, and we had to go back and spend a whole year redesigning everything we had redesigned. And the bottom line is we spent as much money in the end as we would have if we started to begin it doing what we originally set out to do, because we delayed it so much and redesigned it so many times that we could have had all the original capability for the same price. But in order to cut a little money each year and make the politicians feel like they'd accomplished something, we cut out all kind of enormous capability. But NASA had forgotten, I think, why a lot of us in the space advocacy community had originally promoted this thing as a space operations center. And they said, well, what can we do with this? Oh yeah, microgravity. And so they really jumped all over the microgravity aspects of what they would do inside the lab. Now that's got value in and of itself. I think it remains to be seen how much commercial value we can get out of that. And you could think of that yourself. But when we're out here looking at asteroids, when we're looking at these things coming at us from space, to be able to do asteroid divert missions, maybe even asteroid mining missions, to be able to process stuff coming back from asteroids, I think the ISS could be an excellent site for that. especially with the robotic systems capabilities that have been built into it and can be enhanced upon it, starting with the Canadian systems and what they built. Gary and I spent a lot of time going up to Canada working with the Canadians. It used to be called SPAR and then became MD Robotics, I believe. And I think they renamed the company again, but they were located in Toronto. Where they had a big flat floor where they did the shuttle stuff, and they relocated the facilities to a big factory up in Brampton, Ontario. And awesome people up there. It's a great place to go to. They're great engineers, doing great work. And, you know, a lot of people in Texas and we in our various centers work with them trying to develop the robotic systems integration standards. This station has enormous capability. It's got enormous assets on it. Why just throw all that away? Why throw the robotic systems away? Why throw all the habitable modules away? All the strong points to work from, it's got all the radio transmitters. There's so much mass in this stuff. The dumping in the ocean is kind of a shame. If it were really so decrepit we couldn't use it, we ought to find some way to put it to high orbit till we have the capability to smelt it down and put it into other kinds of use. What do you think?
Right. And hence the point that, you know, what you go off and the way you deal with the naysayers is you go through and you identify what the potential outcomes could be. Okay. And, you know, you back off, you know, from that end of life to the different things that you can make use of, you know, well, backing it off to the present. And the bottom line is that in any outcome that you could consider for the station, the most limited, the most, you know, extreme waste would be to ditch it into the ocean. There are so many better things, even just grinding it up for the raw materials would be better than deep sixing it in the ocean.
Amen. That's what I'm saying. I mean, it costs so much money to put material in space. You got refined materials. You got aluminum. You got refined. You've got wire. You've got so much stuff up there. You've got ORUs, many of which can be repurposed. You got power systems. You got thermal radiating systems. And the cool thing about it is they're all integrated into a system that actually works.
Mm-hmm. So you end up having, you know, we from, you know, what my company has been involved in is developing what we call technology development, demonstration, and deployment missions, where the idea is that you may have some notions with respect to interesting things you can do with the tech, but if you actually have to make it work to do something that accommodates some other customer, okay, it provides a critical level, shall we say, of focus in mission requirements pull there. In the space station as a test bed for doing these sorts of you know, TD cubed missions, as we call it, is actually quite extraordinary, because you don't have to worry about having a stable platform with utilities to work from. Okay, it's already there. And what you go and have to do is you figure out how it is that you can handle the particular applications and the experiments that you want to end up doing to, you know, take best advantage of that. And the idea is that, you know, once you conduct an experiment, it becomes part of the infrastructure. So you're continually building, you know, building things out in those regards. That, you know, that in turn, you have a bit of a virtuous circle there, because that increases the capability in the value of you know, of the infrastructure that you've got there. So what we're the point of worrying about this now, as opposed to you know, 2030, you know, if we don't worry about it until 2030, what's going to happen is some you know, some brave soul is going to go through and assert that, well, it's a fait accompli. It's too late to do anything about this now. We didn't do the planning in advance. We haven't The only outcome that anyone's ever thought about is splashing it. So by going through and starting this work now, it goes back. Forgive me, Greg, for bringing Lewis Carroll into this. In Alice in Wonderland, when Alice finds herself at the fork in the road, she sees the Cheshire Cat and says, "But which way do I go?" Paraphrasing the Cheshire Cat, he asks Alice, "Well, where do you want to go?" And Alice says, "Well, I don't know." And the Cheshire Cat says, "Well, doesn't matter then anyway, does it?" The bottom line is that if you have a clue of where it is that you want to go, it's a whole hell of a lot easier to get there. Okay? We have to demonstrate that we've got a clue about where we want to go with this, that we don't want to pay just lip service to commercial development, to expanding our economic sphere into into cislunar space. We want to provide the enabling impetus to do so, and making the extraordinary resource of the space station available on a much broader basis, streamlining what it takes to bring payloads in, using everything that we can learn about each one of the life cycle of each one of the systems and subsystems on the station and each of the elements. It's an incredible laboratory in and of itself to understand what works or doesn't work in the space environment.
So that's all interesting, Gary. Let's talk about, what do you see as the markets for this space station? If we can manage to save it and salvage it, how do you see utilizing it? You mentioned, we talked about two things here. We have talked about as a test bed for something like a power beam experiment. And we've talked about using it as an orbital construction site. And that in itself might be quite enough. Orbital construction and microgravity don't necessarily go hand in hand, because you're kind of shaking a place up. Maybe if people want microgravity, they should have a detached free flyer. And they're talking about putting up all the other kinds of stations anyway. And I think those are going to be optimized for their habitable volume, not the external truss structure, which ISS uniquely sports. So I think ISS may be the best place for an orbital construction shack. But if there needs to be a microgravity test lab or something,
it can be a deployable thing, and eventually it ends up functioning on its own, or ISS can become the utility platform for it. I think the idea that we can expand the available power on station. It was designed to have the solar dynamic systems at the end of the truss. They did not alter the design of the trusses. Okay, when they descoped the solar dynamic systems. Okay, it's designed for it. So that could triple the available power on station. And as we field more extensive communications capability, Illuma-T, which is an optical network terminal, will be added to the station next year. Something called the Laser Communications Relay Demonstration Mission is now flying. This last month, we got first light to both of the designated ground terminals for it. There's a whole evolution of communications capabilities to be had. Turns out that the space station as a environment for deploying science payloads out on the truss has worked out really well, because all the scientists need to worry about is their instruments. The utilities are already there. They don't have to build a separate spacecraft to accommodate them. We're going to be in a situation where increasingly, there'll be opportunity. So for those that can foot the bill to be there. I think eventually we're going to see low Earth orbit as a tourist destination. The beginning, that will probably be facilities that become purpose built for that, but they've got to start someplace and figuring out how to make it work. You're in effect, what for virtually anything you want to do in space, that you would consider doing in low Earth orbit, and in many cases beyond, the station represents a great starting point for anything, because it is in a sense bounded the problem space in terms of what we know. And it's a means for figuring out what we should do next in those regards.
What should we do next? Tell us.
I think our next step in this is defining this advanced propulsion test bed and getting it on station. This may have an interesting effect with a number of our international partners, but one of the curious things is that discovered over the years is it turns out kumbaya doesn't translate into Russian, but playing a damn good game of chess does. So from our standpoint, I think that we can go through and make it in the compelling interests of each of the international partners to play well with us in terms of the evolution of the station. We can figure out, in parallel with working the advanced technology or propulsion test bed, we can pursue what amounts to being the management operations control applications. The damn station was intended to have an evolving level of automation and autonomy. I can tell you with that emphatically because I own the system level requirements for advanced automation and robotics for the program, for God's sakes.
Bingo.
As Greg and I alluded to, our team wrote the robotic systems integration standards from scratch together.
Right. That's right. We know the robotic systems on the station, and it may be the old technology, but what we can do, what we can use that for to branch off into the newer technologies could be mind-boggling. And a lot of people have said, well, ISS is just too expensive to maintain. Nobody could possibly maintain it. I think with the development of robotic systems technologies, that can be beat. And I also think that there's a lot we can do to deal with places where we have metal fatigue problems and things like that. So
it turns out, Greg, this came up in a discussion earlier this evening. The fact that a significant amount of space station is older may turn out to be a feature, because with a lot of electronic systems, their susceptibility to radiation is a direct function of the feature size of the different components in the electronics. They all tend to be significantly larger, on the equipment that's on station now. That's to its benefit. It turns out the radiation environment is far more benign than had been anticipated. A classic example was they're terrified of, computer systems, suffering from single event upset failures. You know what they use for primary computers on station?
Lenovo laptop.
ThinkPads. Yeah. Designed by IBM and remanufactured these days by Lenovo, but it's curious. Now, an interesting experiment was done a few years ago by HP. They took several of their high performance computing modules, commercial off the shelf components, took them apart, blew out, made sure they were really clean, put them back together and flew them to space station and turned them on. during the period of time that they were running, they had only one single event upset failure. It was because an astronaut turned them off.
Oh. Well, for a lot of
Okay.
people, you need to know a single event upset failure is caused when a charged particle like a proton or an electron at high energy goes through and hits your electronics. And it can do several things. It could either fry a little circuit or it could do a bit flip. And so you got what we call latch ups. Sometimes you could get a transistor just latch in place. So there's various little effects like that can happen. Somebody asked, how old is space station? Gary and I were involved in the design of this thing back starting around 89, 90s.
I date back to 1982.
Yeah, but that
I was part of the original mission requirements working group on the technology development.
Yeah, but the systems that actually got into design started in the 90s. That was requirements level. That's why I'm trying to talk about the age of it. Yeah, the program was approved in 1984. We were pre-proposing it prior to that and promoting the heck out of the concepts where I was on the activist side doing that. But the Ronald Reagan approved the program in 1984, which means it got funded in 1985. And it went through many iterations of design concepts, from not even having the external trust, having one time they were talking about having little tunnels that people could transit through, pressurized tunnels for a truss structure. They talked about, they had the power tower, which used a gravity gradient. I'm not going to go on to that, but we had many iterations of ISS. But when it was Space Station Freedom, when Gary and I worked on it before the Russians came into it, I guess we couldn't have freedom with the Russians. I don't know what that meant, but actually the Russians went free there for a while under Yeltsin. So the thing is that the technology in it, dates back from the 90s. But the cool thing, like he was talking, a lot of the technology then, we were so worried about the upsets and things like that. And electronics were so large back in those days. They're not as susceptible as to what we have today. And back in the day, NASA had something called triple E parts, and it still does, where parts that fly on rockets and spacecraft are supposed to be hardened to a high degree and be tested to that degree. And you could upstream commercial parts by taking them through a rigorous test regime to qualify for a grade A part. That's what the top level was called, was grade A parts. Now, the crazy thing is that due to NASA not really buying that much stuff, NASA don't have much say in what gets manufactured these days. NASA's pretty much forced to buy commercial off the shelf stuff for the most part now. And it may not be as robust in general, but the good thing is, as Gary points out, at least for ISS flies, we're more benign. Thing is going through the Van Allen belt, though, on the way to the moon, like the guidance systems for Space Launch System are going to have a bigger challenge. But, we do fly a little bit over the main part of the belt. The main part of the belt is around the equator for guys. So if y'all are worried and think you can't survive it, that's not where you go through. So the other thing about this is that with these electronics, even around Earth, flying around Earth, the biggest challenge is what we call the South Atlantic anomaly. But this stuff is robust. The stuff on the ISS is pretty robust, and a lot of these components, like the power converters, the DDCUs that have direct current to direct current power conversion, those are robust ORUs, or orbital replacement units, boxes of avionics that fit on the space. They're very robust. So I think that there's a lot of value to keep an ISS somewhere up there in the sky for long-term use, whether we just melt it down and reuse it. But look, we got working systems. We got a lot we can do with it. And I really think that as a staging base for bringing asteroid materials back, it might be excellent. Or for processing things going back out. If you want to bring some asteroid material down and process the stuff into fuels, and have an orbital fuel depot associated with it. That could be an interesting proposition. Where look at Starship, it's going to fly Starship up. Hey, I got a couple of them here. They're going to have to fly one up to go to Mars, and then to fuel it, they got to fly up a bunch more to bring fuel to it, cargo versions, and they'll dock them and transfer fuel. Now, one time they were going to dock them tail to tail. I think they're still playing around with that, and transfer fuel from one to the other. And to go to the moon, I think they got to do this like 11 or 12 times. Well, what if you were bringing back the asteroid material and you got enough water in, or whatever other materials you need, carbon-based systems to make whatever fuels you want for going wherever you're going?
it might save you a lot of launches from Earth. So
Actually, yeah, as soon as they, what they'll probably discover when they get it, start getting things figured out, there's an analogous problem where we're looking at, the ability to lash space shuttle external tanks together. And we went on a discovery mission down to the Michaud manufacturing facility where the shuttle external tanks were being made, and to see exactly what was going on with the hard points in that tank. And it turns out that those hard points were used for attaching the external tank to the solid rocket boosters, which required a very, very serious coupling device.
Well, there's a beam inside there. There's a giant beam that goes through the external tank between the fuel tank and the oxidizer tank that the SRB is attached to on each side. Mm-hmm. That's got a lot of structure. It carries a big load.
Right. So what it turned out that to solve the problem of being able to essentially raft the external tanks is you could go and take the connector that had already been designed for joining the solid rocket boosters to the external tank and put a power data grapple fixture between the connector and its doppelganger, made it together, and you had an ability to take advantage of the known hard points. Okay, you had a means of doing so, manipulating it with the space station remote manipulator system or a similar thing. Okay, and you were in a position where you could go through and maintain control over these systems. What we need to be able to do is, and the purpose of that example is to point out that if you actually go to the trouble of figuring out what's going on, a lot of these problems, which seemingly are insurmountable, really are the reason why they're seemingly insurmountable or intractable is because you're looking at the problem wrong. Okay, a bunch of folks tilted at all these elaborate ways that you could lash external tanks together, and it turns out that the best way to do it was sitting there staring you right into the face. Use the damn connections that were already designed the way that they're intended. So what we have to be able to do.
Now we have other vehicles. The Space Launch System is going to throw away its first stage, the core stage. With a little effort, they could get that thing to orbit and make use of it.
It takes fuel to not take it to orbit.
Bingo.
Okay. And guess what? It uses the same damn connectors.
Bingo. Exactly. It's got the same connectors because it's got SRBs on each side of it. So it's a longer tank. So you could do some interesting things with it. It would make a great strong back for a space station or in addition to the current space station, it would make a great construction shack. Wet workshop of sorts is what we used to call things like that back in the Skylab days or pre-Skylab days when they were looking at various space station designs back then. So you could do a lot with a tank like that in orbit. If nothing else, Gerard K. O'Neill proposed to bust them into powder and use a linear accelerator to drive, giving you both pretty good thrust and high efficiency for taking payloads to the moon. So he had his mass driver orbital transfer vehicle concept. And for those that never heard of Gerard K. O'Neill, there's a picture of him, and that's me. Back in 1981 at University of Fairbanks and the University of Alaska in Fairbanks, the Fairbanks campus. So that's it. I'm presenting it to him a pin set right there. So that's what I look like back in 1981. That's Gerard K. O'Neill. So I've been in this space stuff from way back. Now, Gary and I both have a long history of
both space advocacy and of engineering. We've both been involved in this for a long time. And I was early on in the National Space Society. I used to go stay in Gary's house when I go to Washington, D.C. Gary would always put me up because Gary lives up there in the area. And I used to just drive in. It saved me from having to come across those big bridges on the Potomac. I just got to drive down some of the internal streets, like, Massachusetts Avenue and such, getting into DC. It's a lot easier to get into DC that way, guys, if you had to. But a lot of people didn't like to drive in. But yeah, back in the day, you could find parking. It's getting harder and harder to do now. But yeah, I've spent a lot of time in the DC area and running the halls of Congress and having other meetings. Gary's done a lot of that. So we both have a long history in advocacy and such, including the initial advocacy that brought us to the space station, and even the current configuration of having both commercial space and things like the Space Launch System at the same time. That was a compromise that enabled both those to go further. I proposed that compromise to Senator Nelson and put it in the hands of his key space staffer, Colonel Paul Damphus. And he grabbed that and says, yes, I like this. I got to take this to Senator Nelson right away, because they were scorched earth fighting over whether to go all commercial back in the day when commercial was very immature back then. Elon Musk had a very low reliability at that point in time. Now he's come stellar. He's got the best right now. But so we were proposing that, and Senator Shelby, and wanting to promote the Space Launch System, he wanted to kill all that completely, and these guys didn't want that. So there was a scorched earth battle, and I walked into Senator Nelson's office with a compromise proposal, and Senator Nelson adopted it, and he actually quoted from it. So I thought that was quite an accomplishment. I was the chairman of the policy committee of the National Space Society. I spent 10 years doing that as executive vice president, and a term as the chairman of the executive committee of the National Space Society, which is the CEO of the National Space Society, and I was followed by Gary in that position.
Indeed, strange but true.
So we've been cohorts and all kind of crazy things in the past, including a proposal that Gary put forward for space station at one time, and space station program said, hey, we thought the Russians weren't going to be part of us there for a bit. So we were, Gary, you found an interesting box in DC that had something. You want to tell that story, Gary?
Sure. I found myself wandering around a large warehouse on the other side of the Anacostia River, in Washington, D.C. It turns out it's no big secret. It's the Naval Research Laboratory. And I saw this.
There, right? The Ark of the Covenant's there too, right?
Yeah. Okay. I saw this huge crate that was sitting there, and had the side opened on it, and I took a peek inside, and I realized what it was. And I inquired with my chaperone and tour guide at the time what the situation was there, and it turns out it was the Interim Control Module for space station. It was a just in case the Russians didn't come through, we had developed our own by adapting resources from another project. We had developed a propulsion capability for the initial start of space station, just in case there was an issue with the Russians coming through, because there had been a problem where they were running late, and NASA was getting really fuzzy answers for them as to what was going on, until it became clear to the Russians that we had indeed built the interim control module. In which case, after that surfaced, there was never any problems, with the Russians with respect to deliveries. After that, they met schedules, and they became part of history that we made international cooperation work there. But one of the interesting things about that is that it was literally a flight qualified piece of hardware from another sort of program. And the idea that you could take something like that and use it as it, and by the way, in this particular case, it was designed to reboost the space station. Okay, that you could go and take something like that and use that as a, if nothing else, a ground test bed to figure out how you can how you should make the platform a test bed work in space. It's an incredible resource in those regards. And we're we at the time I was raised the issue and sent a letter that day to the director of the Naval Research Lab, about making that equipment available for such purposes, to be of assistance in those regards. And the following day, I was invited to NASA headquarters to have a nice chat with them about what it was that I was doing. Turns out that it was very topical at the time. There's some issues with respect to some equipment being scavenged from it, but it's still if nothing else, it's still useful from a ground test bed standpoint. And when we're looking at what it would take to build something that would be suitable to purpose, it's kind of nice to have a piece of flight hardware that's designed to do exactly what it is that you wanted to do.
Yes.
So from that standpoint, it's there's this is not a fantasy. There are there are real things that can be done. There's existing hardware that can be leveraged, if nothing else, for ground testing. And there's a path forward. We just have to be engaged in working on it now. Not waiting until 8 years from now.
Okay, so that gets to the next good point. How do we actually get this started? You've got a history of starting such crazy things yourself in the past. So what's the next step to actually put together a cogent proposal and putting it in the right hands and getting some of the appropriate backers? We got to find somebody with money to back this who might see value in it. Bezos talks about asteroid processing. I could come up with a whole concept for him for asteroid processing, how he could we could use ISS and as the orbital element. You could drop this stuff in the Gulf of Mexico and fish it up the Alabama River and get up to Tom Bigby and get into our steel mills and engineering facilities up here. So we got a lot of facilities here that would be good infrastructure for an asteroid material processing venture if somebody wanted to go down that road.
So I think that what we need to do is for each, the reason why we ended up having a space station program to begin with was that the so-called one-trick pony designs didn't work, because there was always somebody that could say, well, there's issues with that or this or that or what have you. Okay, so what we ended up doing for space station is we came up with something called a mission requirements database that had over 1,000 potential missions on it that were vetted through different interested stakeholders, and the NASA organization. And at that point, that was brought to Congress, and the whole issue of, well, what the hell would you do with it, became moot. In those regards. So by going through now and essentially reverse engineering a range of different missions and applications that can be performed, that makes effective use of the equipment in whatever state it's in and how we choose to evolve it. That is one piece of the puzzle. Secondly, we need to go through and near term start laying out experiments that can be part of the building blocks for carrying this forward. And they should make sense not just as a NASA play, but they should make sense as a commercial play. Basically, have design things such that you can get enough out of the investment that it makes it worthwhile to go forward, even if it was a pure commercial play. And brings it back to this idea of the technology development, demonstration, and deployment mission. You want to go through, and for every increment of resources you invest, you want something of demonstrable value to come out of it, that one or more other missions can use and find a value. That builds the constituency, for what we're doing. And NASA will either get out in front of this and help lead it, or help facilitate it, or get out of the way. Whichever, and they're probably going to do a little bit of all three.
Well, there you go. Lead follower, get out of the way. That's the old saying. And we would leave NASA the risk of having to dispose of the thing, basically. Of course, that might mean we're taking on the risk of keeping it, because it's going to cut, if it goes to 100-year orbit, we've either got to reboost it or drop down. The cool thing is, if we decide to really not man it, and it was decaying, we could boost it to a higher orbit right in the Van Allen belts. You just wouldn't want to go there.
And actually, will one of the things that we can go off and do is do the orbital calcs to establish where we can put it and how quickly. And it turns out that XISP Inc. now has the tools to do that.
Yeah. So what he's saying, XISP Inc. is Gary's company.
Yeah, Extraordinary Innovative Space Partnerships Inc. Yeah.
And he also has an ISP service. So
XISP.net, absolutely.
So Gary gets dual use out of that name.
And my vanity license plates. I didn't have to change them.
Isn't that amazing? Isn't that amazing? Dual use.
Mm-hmm.
So
Great fun.
I'm working as a safety engineer these days. I like redundancy.
Great fun. Well, Greg, one of the things that we can also do is that we can pull together a slide deck in terms of what's going on here, and make that available as a link from your site, and stir up some opportunities.
Nice slide deck might make a good alternate comeback, another presentation. Might take another bite at this apple. I accidentally hit the go live button. I didn't realize I was live. When I was kind of monkeying around with some stuff, and I started hearing the chat. Why am I hearing my chat on Gary's thing? And I realized I was actually live. It's like, wow. So that's going to be kind of awkward starting the video, but once it's posted, it's posted. It's kind of funny.
Right. Well, we can revisit that, and we can, there's some very nice graphics that we can make available that should, I think, prove of interest to all concerned. And
so one thing that Gary's quite engaged with is a lot of the people at NASA headquarters, a lot of the people that has been at the helm of the space station program, people that's been on the space station. He's been very engaged in, he and I both used to work for a company called Grumman. Now it's Northrop Grumman. And we had the space station integration contract back in the space station freedom days. And the Grumman, I worked in the field office at Marshall Space Flight Center. The main office was in Reston, Virginia, which is close to where Gary's at. And so there's quite a few people still in that area that Gary's quite engaged with. So, and they still meet pretty regularly. So it's quite possible to come up with some kind of potential solution set to make this thing happen. So what do you think about that, Gary?
Absolutely. Basically, we can come up, with both with a public-private partnership proposal, and as opposed to it being something that has to that can be shopped in its own right, and the precursors to it can be missions that can be defined immediately.
Amen. 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 Well, there's a lot that can be done. There's still a lot that can be done. We just need to make sure that we find some good commercial hooks to pull the commercial people into it, and somebody with deep pockets. We need somebody with deep pockets beside the government to become an integral part of this. So we need to work the contacts. Now you've actually got contacts and with Bezos, so it might be possible to pull on that a little bit. See if he's got an interest in that. We just got to make sure you don't drag his feet like his Blue Origin does today. They're really bad at dragging their foot. It's been a lot too much energy suing and not enough pursuing.
Right.
They need to be burning more rocket motors instead of lawyers. Money to send to lawyers. Yeah, so hopefully we can get him engaged. He's got a big dream. He's got a good dream, at least in the space side. But here on Earth, he's kind of like the Darth Vader in many ways with Amazon taking over everything. But at least he wants to see orbital space colonies and stuff like that, more of the O'Neillian vision, which I think is in mining asteroids, which I think is a little bit more credible of at least a business venture than going to Mars. Mars is kind of a one-way ticket. But Elon's definitely invested in that. Anyway, so Gary, I appreciate everything. You got any final words you'd like to add or throw out here to everybody?
Well, the bottom line is, let's not wait for the future that we want to see come to pass. Let's help build it.
Well, we've been a big part of that many times, haven't we not?
Indeed.
And for those that don't know, I've had my piece of that. I got a piece of it right here. This used to be the future. It's the past now. This is a hybrid rocket motor solid fuel grain for a test motor for the Cat's Prize motor. So yeah, I've done my share of that. That was my company, High Altitude Research Corporation. Spun off from our club, HAL 5, and the grandchild of that motor is on Virgin Galactic Starship, but not Starship. What do they call that thing?
Spaceship 2.
Spaceship 2, yeah. We got so many starships, spaceships, and names floating around there. It's easy to get them crossed up. So yeah, so that's where that bit too. And we've had some adventures. Definitely had some adventures.
Indeed. Well, it's been a pleasure talking with you, and let's revisit this again, and we'll give some more illustrations to it and some opportunities for folks to engage.
All righty. Well, I want to thank everybody for joining us here tonight. And I got to make some people mods. I just realized I don't have any mods in my live chat here, so that's something I'll have to do. I'm used to having mods watching. Unfortunately, I don't think anybody's coming here with anything bad. So yeah, I'm gonna make a bunch of you guys mods. So hang on a minute. I'm gonna make a couple people mods before I log off here, so there'll be mods when they start out. Gary, before we end this thing, moderator. Yeah, I just want to do that. Some of my more regular people that I know who will take care of business, keep people from saying bad stuff or posting bad stuff in here. I'll make a few people mods here. I got my regulars. Mostly they're people who watch both my channels.
And Greg, there is an IAC, International Astronautical Congress, paper that it's entitled Evolution of ISS as a Technology Development, Demonstration, and Deployment Infrastructure to Support Commercialization of Low Earth Orbit and Beyond. Kind of a topic we've been dancing around here.
There you go.
I'll send you the link.
Okay. Well, you definitely got a lot of good contacts to pull this together. I've had my little local company, Heart. We can support it as such. And so let's see what kind of trouble we can make. We're pretty good sometimes at making trouble, right?
Yeah, on a constructive basis. Yeah, that's the idea.
Constructive basis. Exactly.
And somebody here says we need to be about saving the earth. Exactly. That's what we're about, guys.
Mm-hmm.
Very definitely. All right, Gary, thank you. Thank you, everybody, for watching. Share the video widely. Give us some thumbs up if you hadn't already done it. Helps with the algorithm. Has no rhythms. And, Gary, what